Hello everyone, we are from Group E and today we'll be presenting our Project 4 for Statistic 2 about ANOVA and multiple linear regression. And here our member, we have Arnada Pratama, Chile Angreina, Dimas Mahendra, Divka, Manuel Favio. And here our four main bullets that we will be discussed further. The first one we have problem background. The second one we have methodology. The third one data and analysis. And the last one is conclusion.
Background: calculus is a fundamental yet challenging subject in secondary and tertiary education. Student performance in calculus can be influenced by classroom-related factors such as teaching style and research availability, as well as individual behaviors like study time and sleep duration. The study examines two key aspects of calculus achievement. The first, class level difference. Using one-way ANOVA, we compare test scores across three different classes to determine whether significant difference exists, potentially due to varying instructional methods or class environments. And the second, individual level predictors. Through multiple linear regression, we analyze how daily study hours and sleep duration impact student performance, offering insight into how personal habits relate to academic outcomes. Together, this analysis aims to provide data-driven recommendation for enhancing both teaching practice and student learning strategies.
So in this slide, I will briefly explain the objective of our study. The first one is we aim to evaluate the difference in calculus test score among three different classes using one-way ANOVA. This helps us determine whether class membership significantly affects academic performance. The second one is we develop a multiple linear regression model to predict student test scores. The model is based on two independent variables, the number of hours spent studying and the number of hours spent sleeping per day. And the third one is we interpret the regression coefficient to understand how changes in study and sleep habits relate to test performance. And lastly, we provide a recommendation for both students and educators based on our statistical findings, aiming to promote more effectively study habits and teaching strategies.
For phase one is ANOVA, we want to evaluate whether there is significant difference in calculus test scores among three different class 1, class 2, and class 3. We collect scores from 10 randomly selected students from each class. The scores are as follows. Using a significant level of 0.05, test whether there is a significant difference between the average score of the three classes using one-way ANOVA. And the first step, we set up the hypothesis and then we calculate the mean. The average of class 1 is 78.4. The average of class 2 is 81.8. And the average of class 3 is 81.1. And the average for overall data is 80.43. And then we calculate the sum of square between groups and we get 94.47. And then we calculate sum of square within group or SSE, and we get 1852.6. And then we compute main square MSA, we get 32.23, and MSA is 68.43. And then we calculate the F statistic and we get 0.4703. And then we determine the F critical value, and then we get F critical value is 3.35, and F statistical lesser than F critical value, so we reject the S null. There is not enough statistical evidence to conclude that the mean calculus score are different between three classes. And then for the software calculation, we get the sum result. We not reject the its null.
For the multiple linear regression, for this case, a teacher want to understand how student study habits and sleep pattern affect their test score. She collected data from 30 students recording number of hours each student studies per day, how many hours they sleep per night, and their most recent test score. She is interested in using multiple linear regression predict student test score based on, based on their based on these two variables, study hours and sleep hours. Using the data provided, calculate the multiple regression equation manually, then interpret the meaning of each coefficient, predict the test score of a student who studies 6 hours and sleep 6 hours, and draw a conclusion based on the model. For our data, we use variable study hour as x1, sleep hour as x2, and test score as y. And this is our 30 data. Next slide. For the first step, we begin by calculating the average each variable. Mean of x, we got 5.7, mean of x2, 5.73, mean of y, 79.10. And after that, from the dataset, we already compute the necessary summation, including variance that is 17.63, and we also have covariance with y and between x. For example, x and 1y is 129.1, and x to y is 49.55, and x1 x2 is 27.45, and we compute the denominator used in both slope coefficient formula, and we get 205.27. Also, now we calculate the regression coefficient. For the coefficient for x1, we got 4.47, and the coefficient for x2 is minus 4.14, and we calculate the intercept beta. We got 77.30. So the final regression equation becomes y 77.33 plus 4.47 xy minus 4.14 x2. And for the prediction example, predict y when both x1 and x2 are equal to 6, y is equal to 77.30 plus 4.47 and minus 4 14. We get the result is 79.31. Next slide. And this is, we do the software calculation also, that we have same result. Study hour or in variable x1 for its additional hour. A student studies, they predicted the test score increased by approximately 4.47 point, assuming sleep remain constant. Sleep hour variable x2 for its additional hour of sleep. The predicted test score decreased by approximately 4.14 points, assuming study time remained constant. The model suggests that study time has a strong positive impact on test score, while excess sleep in this dataset show a slight negative correlation with performance, possibly because more sleep might reduce study time or reflect lower preparation. The prediction for a student who study 6 hours and sleep 6 hours, approximately 79.31, which align closely with the average score in the dataset, 79.1, indicating the model fits the data. Next slide.
So the conclusion, the study evaluates student performance in a calculus course by examining class level differences and individual behaviors. So class comparison, one with ANOVA, which the result is no significant difference in test score among the three classes were found, suggesting consistency in instructional quality across groups. And individual behaviors, multiple linear regression, study hours positively impact test score plus 4.47 points per hour. Sleep hours, like negative relationship, minus 4.14 points per hour. Study time was a stronger predictor of performance than sleep duration. So the key insights are focus and consistent study habits have a more substantial impact on calculus achievement than classroom differences or sleep patterns. So the recommendation is students should prioritize effective study routines, and an educator can use these findings to support evidence-based teaching and student guidance. So I think that's all for our group. Thank you.